In this video, I'll be going over the section 7.7 day 2 notes. We're still talking about the base e and the natural logarithm, and we're going to be solving equations that have either the natural base of e or the natural logarithm involved in those equations. So we'll start with these exponential equations for problems 1 through 4. So in problems 1 through 4, when you have the base e, the first thing you want to do is isolate it. Okay, you want to get it by itself on one side of the equation. So I'm going to start by adding the 5 over. And then I will divide the 4 out front. Now at this point, usually what would happen is I would try to get bases to be the same. So if I show you real fast a previous problem, okay, I'm going to compare this, don't need to write this down, but let's say I had 4 times, let's say 2 to the negative 2x power minus 5 is equal to 3. Well, I would still add the 5 over, and I would still divide by 4, but my plan or my goal would be to get bases to be the same, and as you can see right here, the bases are the same, so what would happen is I would take this exponent and set it equal to this one, and then solve for x. But the problem is, when my base is e, there's a good chance, and probably it's never going to happen, it's really hard to get those bases to be the same. So, very important problem here. What you're going to do is take the log on both sides. So this brings up another important point that we saw previously. So what if I had, let's say, 5 and then 2, right? So if I can't get bases to be the same, which 5 and 2 can't, I would take the log on both sides, so that way I can move the power out front by using the power property of logarithms, and then I would solve for that. The issue here is that I'm using base 10, but since in the problem that I'm looking at on the note, since it's base e, it might be better to take the natural log on both sides. So you can do it with base 10, but it's so much better with the natural log, since the natural log has a base of e, and e is already in the problem. So I'm going to go ahead and kick that power out front now that I have taken the log on both sides. So this is going to be, and I'm going to move up here, negative 2x times the natural log of e is equal to the natural log of 2. Something really nice happens right here, the natural log of e. So if I take my calculator and take the natural log of e, I'll put a power of 1 on it, I just get back 1 because the base matches the e that's already in the problem. And so that natural log of e just goes away because when you multiply something by 1, it doesn't really change it. So then to finish this problem, I'll just divide by negative 2. Now if I had used log base 10, that part would not have canceled at all. And that's why I picked the natural log. The natural log of e, and I want you to write this at the very top of your paper, the natural log of e is 1. Very important. So you would type this into your calculator, natural log of 2, close that parenthesis, and then divide it by negative 2. And you're going to round that to 4 decimal places. So that is going to be negative 0.3466. Right, so when bases can't be the same, you take the log on both sides. But when one of those bases is e, you're going to take the natural log on both sides. So for problem number 2, I'm going to add the 12, and then I'm going to divide by 3. So I'm going to do that all in one step. So 15 plus 12 is 27. 27 divided by 3 is 9. Now e and 9, those bases can't be the same, so then you're going to take the natural log on both sides. And then you're going to bring the 4x out front. And a lot of times what you may see me do, it's kind of up to you, you might not even need to write out ln of e. If you know that's equal to 1, then you can just say 4x is equal to the natural log of 9, and then just divide by 4. So with that, I would take the natural log of 9 and divide it by 4, and that rounded is 0.5493. And in essence, that's what these 4 problems are about. There's 2 more here that I'm going to go over, but these are kind of the whole, this is the exact same concept over and over again here. So for problem number 3, I want you to subtract 17, and then I want you to divide by 5. So you're going to have the following here. Oh, that should be -3. Okay, so -18, -15 divided by 5 is -3, and then you're going to take the natural log on both sides. So red flag should, you should see something that's happening here that's not allowed. You can't take the log of a negative number, so then that means this problem is no solution. I don't even have to finish it. Cannot take the log of a negative number. So then for number 4, you would get the following. I would subtract 8, that's 9, and then you would get 9 divided by 4, which doesn't break down. So then you're going to take the natural log on both sides. Move the power out front. And then get rid of the natural log of e. And basically you're just going to divide by a negative. So I'm going to take the natural log of 9 over 4 and then change its sign. So the natural log of 9 over 4 is positive, so then my answer is going to be negative 0.8109. So as I mentioned before, it's the same concept over and over again, though number 3 is important because we can't take the log of a negative number. So then this brings us to the last part for today. What happens when there already is a natural log present in the problem? Well, just like before, we want to get that log by itself. So for problem number 5, I'm going to divide by 3 on both sides. So I get the natural log of 4x is equal to 8. There's no reason to use a log on both sides because I already have the natural log present. So you are going to convert. You're going to convert. And I say convert because usually when you have a problem that looks like this, so let's say the log base 3 of 2x is equal to 8, the way that you would solve this is you would take the base, you would take the power, and then you'd set it equal to the term in the middle, and then to solve this you would just divide by 2. I'm going to do the same thing here for number 5. I'm just going to involve e because e is the base. So this would be e to the 8th is equal to 4x. All you have to do is then divide by 4. So this is e to the 8th divided by 4, which you can type that into your calculator. So you have to hit second ln, close the parentheses around 8, and then divide by 4. And so you get 745.2395. But notice how I'm just converting here to get that answer. I don't need to reintroduce another logarithm or anything like that. So number 6, the log is by itself. So this is e to the 6 is equal to 2x. Divide by 2. And then type that into your calculator. Should be around 201.7144. And there you go. So there's a big difference between problem 5 and problem 6. These are actually less work than problems 1 through 4. And problems 1 through 4 are more work because you get to the point where you can't get bases to be the same. There's no converting to be done, so you have to take the log on both sides. And it, in this case, has to be the natural log to make it a little bit easier on you. But 5 and 6, all you have to do is convert. There's your video for today.